Good evening and welcome to the Team Idris channel and an argument between me and my friend on the internet about valve seats. So what do we got? This is an F head, so it's got four valves in the block and 4 in the head, which is a bit odd, but it's a 1930s design, but that'll do for this one. We've got quite small valves here. So this is the running face of the actual seal. These valves have been ground back and they seal against this face, which is a hardened seat, a hardened ring pressed into the cast iron of the block. So in goes the valve. When the piston comes up after it's fired, this valve's open, exhaust gas disappears down this gap down here, out through this branch, out down the exhaust pipe and out the back. So to make sure that that seat is good in there, because the burning can create pitting marks in here, a bit like sort of a cavitation, but heat cavitation, and that's where this fella comes in. This is the 46 degree, I think it is, and the other one's similar but 30ish. This goes in here with a guide and you turn it, and these hard cutters here cut the seat back, and that's quite a handy tool to own. I bought it the other week off somebody I used to work with. And this one, this valve, I think sometimes these are welded together. The end is welded onto the shank there. This is the bit that runs in a guide, and the spring goes on the end. I haven't got any springs out at the moment. So to grind this one, you grab it in a very accurate chuck and you work it past the grinding wheel that makes that absolutely a perfect angle. Because the angle between this seat and that want to be 1 degree different, so that the seat is more on the outside than the inside, because the gas pressure is on this side, so you don't want a V shape that the gas could get into. You want it to be the other way. The gas pressure is hitting the V with the gap in between the valve and the seat. So there's like a sort of jeweler's rouge, sandpaper in grease sort of thing you put on here to make it a perfect fit. So yeah, you've ground that, machined that seat by hand. This has been done by machine. You've got a very good seal, and to make it absolutely perfect, you get a rubbing stick with a rubber sticker on the rubber, a bit like a bow and arrow, isn't it? Stick that on there, rub it, maybe a bit of oil on it to make it easier. So why is that better than getting your battery drill and there we go, get your battery drill, sticking your battery drill on there and work it in. Well, the argument is, I'll find a valve guide. This is the bit that the valve actually runs in, the valve guide. Call Mr. Valve. So down in this hole is one of these. The spring goes on here, the bit that pushes it is underneath, and this sits in here. And this isn't completely tight. It can't be, because when this engine gets up to past maximum temperature, what you really don't want to happen is to this valve to get so hot and so expanded that it jams out. Now on this engine it should miss the piston regardless, but it's still a bad thing to have that valve half stuck in, half out. So when this is going across the desert, really hot day, pulling a trailer, you want these valves to be free. So that bit of play. So this comes on to the point of the video. Why is the stick better than the drill? Well, the argument is tiny radial grooves. You can sort of see some grooving around there, but the idea is that the grooves on here match the grooves on there. So rather than the valve being free to wiggle around a little bit in the seat, it's always going to try and sit in the seat, but the grooves are going to make it sort of, if the grooves are this way and the grooves are that way on the valve, they're going to kind of latch together. So the argument is that the drill is going to be more prone to creating those grooves because the valve's going to sit in one plane. And I think what they're saying is on the internet, because some people are saying, yes, it's very important, and some people are saying, no, it's not, is that one hand is always going to be stronger than the other. So although it looks like you're just rotating the valve as you work your way down the stick, what you're actually doing in the action is you're, oh, goodbye 5/16 spanner, pushing the valve one way and pushing it the other way. So, my argument is then, really, if you wanted to do an excellent job of lapping the valves in, so you've got the seats cut, you've got the valve cut, everything's great, you got in with the fine one, you bring the drill in, and you reach around the valve, which has got the oily shank on it, and as you work the drill, you move the end of the valve, round with your fingers underneath. And it's sitting in the seat like that. You've got hold of it with your fingers underneath there lightly, and you move the end of that valve around under there. It's only going to move a few thou, but if you move it around with your fingers while you're spinning it with the drill, you should actually get a better job than both, because as you're moving it around in that seat, these lines are going to have to cross. They're going to, if the grooves on the seat and the grooves of the valve are like that, they're going to have to do that slightly as you're moving the end of the valve round in the seat. So that's the theory. I've always done it with a drill, very rarely done it with hand. Never had any warranties with anything. But it was an interesting argument about if you did it with the drill, you created grooves that held the valve in one position. If you did it by hand, you got a better finish, and the valve was free to move around and landed wherever it landed and bounced in there. So not a bad argument, but yeah, I think if you use a drill and you move it around with your fingers and apply force this way and that way as you're doing it, I think you'll get the most of both worlds. Equally, we were discussing how in the back in the day with soft seats on Ford Escorts and things, get the valve in there, they get a hammer, bang bang, and that was it. That was it, literally seated. They didn't lap them in at all. They just banged them. The valve impacted the seat, and that was the finished product. So, yeah, how nice do you want it to have it? Probably as nice as possible. I'm not bothered on this. It's 40 horsepower, long stroke. It gives the valves hell, but not at a high speed sort of hell, just with temperature as it fires raw petrol through itself, being a 1930s design. So yeah, valves. Lapping valves. Do it which way you like, I think. I don't think it's going to make a lot of difference, but if you really, really care, think about not creating grooves in the valve. Thanks for watching.